Hey guys, happy Thursday. So we're going on day 3 of dilations, right? And so I want to review what we've done so far as skill factors and then actually performing on dilation when you have like that anchor point. And then a new one today is you're going to perform the dilation, but it's not going to be at a specific point in the shape. And I'll talk a little bit more about that today. Um, so same as yesterday, I will be collecting your guys' notes and your class activity. So again, I would recommend you do your notes on the front side of the page and then flip it over on the back side. You guys can do the class activity. All right, so get that title down, performing dilations, day 3. Okay, and the goal is, again, by the end of this, you should be able to perform a dilation that's not from a specific point, but the center, and I'll explain more of that in a second. So recall what we've done. Find the scale factor for the pre-image A to the image B. Now again, remember when we were finding scale factors, it was a simple little formula, right? Scale factor is equal to new over your old. Okay, now make sure you guys understand which is which. So the pre-image A is the old one, and the image B is the new one. Okay, so let's go ahead and label it over here. So I know it's kind of hard to see, but this one right here was A, and this one over here was B. Okay, so let me label this image B as the new. Okay, and image A as the old. So based off just the pictures alone, we can see that, hey, that was a reduction, right? The type of dilation, it got smaller. So we know it's a reduction. Now let's figure out the actual scale factor. By how much was it reduced by? So pick a side. Again, I'm gonna be a little lazy here. Actually, no, let's do it this way. I'll pick this side. So the new one, so start off with the new goes on top. This side is 2. Why is this not writing? So this is a distance of 1, 2 spots. Okay, so the new one is 2. The old one, however, if I compare it to the same side, it's 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, and again, I always want to simplify my scale factors here. So we divide the top by 2, the bottom by 2, and I get 1/5. And again, 1/5 is a fraction between 0 and 1, so it makes sense. Hey, this was a reduction. Again, I went from the old image to the new image, it got reduced in size. All right, so that's number 1. You should know how to find a scale factor. You will be tested on that next week. Okay, now if I move on to the next slide. Okay, and then on Tuesday, we started actually performing the dilations, right? And I told you guys, hey, it's very, very important where we're standing, right? Dilate the triangle using a scale factor of 1/2. So this 1/2, I know it's going to be a reduction because it's between 0 and 1. All right, so my triangle should be getting smaller, but here's the important part and the difference between what we did on Tuesday and what we're going to do on today. U as the center. So this U right here, that is the center. Everything that I do is going to be based off of that U. So I'm going to actually count the spaces. So this was 1, 2, 3, 4 spots. This was a distance of 4. Okay. And this distance right here from U to V was a distance of 2. Okay. So what do I have to do now is I actually have to apply my scale factor of 1/2. So how do I do that? You multiply. What's 4 times 1/2? Well, it's 4 over 1. You multiply across the top. You get 4. Across the bottom, you get 2. What's 4 divided by 2? 2. What that means, again, it's a reduction, so you're making it smaller. And the big idea here is that the center was U. So if the center was U, I used to go out 1, 2, 3, 4 spots. This time I'm only going to go out 2, and I stop there. That is what we're going to, again, think of it as W got a little bit closer, and that's now W prime. This is now U prime. Okay. Now let's figure out the other side. This was a distance of 2, but it's getting a reduction by a scale factor of 1 over 2. So if I multiply that out, 2 times 1 is 2. And then 1 times 2 is 2. What's 2 divided by 2? That's just 1. So this used to go up a distance of 2 from the letter U, that's my anchor point, all the way up to V. Now I'm only going to go up a distance of 1. And that's going to be my new V prime. All right, and there we can actually finish up that triangle right there. So notice it was a reduction, so everything shrunk towards the letter U because that was my center. All right. Now, what's the difference between this and what we do today? So again, I was giving you guys on Tuesday a specific letter. I can say V, W, or U, and you're counting based off that point. All right. But now it's going to be a little bit different. Okay, now I'm telling you guys the center of dilation is going to be 0, 0. That's going to be what we call the origin. All right, so again, 0, 0 is going to be the point of dilation. So now I actually have to work with the coordinates. I can't count the distance between A to C or A to B. What I want to do is I want to work with the actual coordinates. So here I did a little bit of work for you guys. So the original coordinates, so if you see A here, it's sitting at the origin 0, 0, right? So that's 0. B is 0, 4, so you stand at 0 and you go up 4. That's there. And then C was 3, 0, so you scooted over 3 and you stayed at 0. Okay. Now, I want to dilate this by a scale factor of 2 for the first example here that we do. Well, what we're going to have to do is I can't just count. When I'm working with the center being 0, 0, the origin, I actually have to use the coordinates, and it's not too hard. All you're really going to do is scale factor is 2. I'm going to multiply all of my coordinates by 2. Okay, so what's 0 times 2? What's 0 times 2? What's 0 times 2? What's 4 times 2? What's 3 times 2? What's 0 times 2? That's going to give me my new coordinates, and I can actually graph the image here in a second. So let's go ahead and do that. 0 times 2 is 0. 0 times 2 is 0. All right, it's kind of nice. 0 times 2 is 0. 4 times 2 is 8. 3 times 2 is 6. 0 times 2 is 0. So these are going to be now my new A prime, B prime, and C prime. So let me go ahead and graph that. So A prime actually ended up being in the same spot, right? Okay, that's fine. It was just a coincidence. But B now got kicked up to 0, 8. So 0 all the way up to 8. That's going to be my new B prime. Okay. And then my last one here is C prime is 6, 0. So I go across to the right 6. And I stay there at 0. That's going to be my new C prime. And I can actually draw the new triangle that got scaled, whoa, by a factor. Okay, whoa. By a factor of 2. And it makes sense, right? If your scale factor is bigger than 2, it's going to get much larger. Okay. Now again, I could go through the same thing with the scale factor here. Scale factor of 3. Let me clear the board. Give me 1 second, guys. Okay, so now that it's clear, let me use the same coordinates, right? Still A, B, and C, so they're still there, but now by a scale factor of 3. So each one of these gets multiplied, right? Each of the coordinates, we're going to multiply it by our scale factor. And again, why am I working with the coordinates and not just the distance of the legs? Because again, our center is at 0, 0. Whenever it's at the origin, you have to work with the coordinates. So if I do for A prime, that would be 0, 0 still. That would be 0, 12. The next one would be 9, and then 0. So again, A prime again for this one stays there. 0, 12 would be B, so all the way up to 12, that would be B prime. And then lastly, 9, 0, all the way to the right, that would be C prime. And again, that would be our new, if I can get this a little bit straighter, our new triangle after scale factor 3. Notice scale factor 2 wasn't that large. Scale factor 3 is making it much, much, much larger. Okay. Now, what I want you guys to do is I want you guys to try this one. All right, so you have your square here. All right, I gave you guys the coordinates. What I want you guys to do is give me the new coordinates. So give me A prime, B prime, C prime after a scale factor of 2. Same thing with the scale factor of 3. When you're ready, hit play, and I'll have this graphed for you. All right, so I did the scale factor of 2 for you guys. So again, you can check your points, make sure you guys have them all correct there. And then I actually went ahead and drew our new coordinates here. I drew a new square. And now notice before, right, when you had that anchor point of something like B, we were counting based off B. And this would have stretched out from B in this direction and then B going down in this direction. But now because your center of dilation is at 0, 0, here the origin, right, it's kind of getting blown up based off of that center. It's expanding kind of away from that middle instead from an actual point, right? If I go back to that triangle that we had before, hopefully it's all still there. There it is. So notice everything was kind of shrinking towards you. It wasn't based off the origin. All right, so again, when it's based off an actual axis here, you want to make sure you count the distance versus when it's based off the center, that's when you're forced to use the actual coordinates and multiply by your scale factor. All right. The next one, I won't do it. It'll get kind of too messy here, but here are the coordinates, what you should have gotten. All right. All you're really doing, guys, is multiplying by that scale factor, all of your coordinates. Okay. Now let's do one more here. Still, your center of dilation for this one is 0, 0. Okay, so it's the origin. Now again, it happens that this triangle also lands, the A lands on there. But how does it work when you have something like a scale factor 1/2, scale factor of 1/3, scale factor of 1/4? If you haven't figured out the 1/2, 1/4, 1/3, guys, all this really means is you're dividing by 2, you're dividing by 3, you're dividing by 4. Okay, so let me do the first one for you here. I'll do it in red. So you technically are multiplying by 1/2, 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 and multiplying by 1/2, right? But when you multiply by 1/2, you're dividing by 2. When you multiply by 1/3, you're dividing by 3. When you multiply by 1/4, you're dividing by 4. So 0 divided by, whoa, what happened? 0 divided by 2, still 0. 0 divided by 2, still 0. 0 divided by 2 is still 0. 12 divided by 2 is 6. 12 divided by 2 is 6. 0 divided by 2 is 0. So these are going to be my new A prime, B prime, and C prime when I apply a scale factor of 1/2 when my center is at 0. So again, I should see everything kind of shrinking towards the origin, 0, 0, because again, it's a reduction. So let me actually do that. So A prime still stays there, right? Because it just happened to be a coincidence that A landed on the 0. Now, what about B? Notice it's getting shrunken down. It's getting pulled towards the origin. It's now going to be at 0, 6. That's going to be the new B prime. Okay, so there we have it. And then what about my C prime? Well, it's getting, again, same thing, getting pulled towards the origin because this one was a reduction. All right, and there we have it. That's my new C prime. If I can hopefully get that as straight as possible. All right, what I want you guys to do, you don't have to graph this one, of course, but I do want you guys to give me what are the new coordinates. So what's A prime, B prime, C prime, A prime, B prime, C prime, after you guys apply the scale factor of 1/3 and 1/4. Take a second. When you're ready, hit play. I'll have those answers for you here in a second. All right, guys, so there are the new coordinates. That's what you should have had. And again, every time, right, I went from 1/2, dividing by 2, dividing by 3, dividing by 4. Again, it's a bigger and bigger reduction. We kind of keep making that triangle smaller and smaller. And again, it's shrinking. It's being reduced towards the origin. Okay. All right, guys, here's your class activity. So I do want you guys to graph this, right? So here's your triangle. You have 3 different problems. Apply a scale factor of 2. And again, this is from the origin, so you shouldn't be counting distances. Get the coordinates here. This is sitting at 2, 4. So I'll give that to you. This is sitting at 4, -2. This is sitting at -2, +2. So again, you're going to be working with the coordinates. Apply your scale factor of 2 and sketch out the new actual triangle. Apply the scale factor of 1/2. You're going to divide all of these by 2. That's the secret. Apply the last one, scale factor of 3. Multiply each one of these by 3 and actually graph it. Okay, so again, you guys know the deal. When you are done, check your answers with my sub. They should have the answer key if everything's perfect. Turn it in, work on missing assignments. Also, again, make sure you turn in your notes with this. All right, so your class activity, you'd want to probably do it on the back of your notes so you can just turn in one page. But I will be looking for both the notes and your class activity. All right, guys, have a great day. I'll see you guys soon.